Section 1.3, homework problem number 3. In this section, we look at how to compare two numbers to see which one is bigger. For example, in the homework, we're asked to compare these two numbers. Generally, we can start from the largest place values and compare them to determine which one is bigger. But in order to help students understand this method, why this method works, we can use real objects to help them. So for example, I have 1.2 and 0.899. So of course, normally we just compare the ones place, say 1 is bigger than 0. Of course, 1.2 is bigger than 0.899. But before students learn these, we can use objects so they can visualize 1.2 is either longer than 0.899 as paper strips, or 1.2 has more toothpicks than 0.899 if we use bundled objects. Or we can put them on the number line. We can see 1.2 is to the right of 0.899. So we have these three different methods to help students visualize, to see why 1.2 is larger than 0.899. So let's look at these three different methods. The first method is to use paper clips. Use paper strips. So we want you to use strips of paper. And here for homework problems, you don't have to use real objects. You could just use drawings to show paper strips. So for example, here, first we want to use paper strips to demonstrate 1.2. And remember, let me mark the place values. So this is the 1's place, and that's the 10th place. So first we're going to start for paper strips method. We want to start from the largest place value, which is 1, the ones. So we take a long paper strip, as you can see here, and we're going to use it to represent 1. So how long this paper strip is from the left end all the way to the right end, that is 1 unit. And next, we're going to generate the tenths from ones. And as we know from the previous section, we learned section 1.2. How do we obtain the tenths from the ones? And we can divide 1 by 10. That's going to 1 divided by 10. That's going to give us 1/10 or 0.1. So this is how we generate the place value for the tenths. So which 1 divided by 10, which literally means we take this paper strip and cut it into 10 equal parts. I didn't really show it here, but you could do that, and you just use a ruler or to help you to cut it into 10 equal parts. So after, I'm going to just do a rough drawing here, so it may not be the exact side. I don't really have a ruler to measure here. All right, so once you have that, you can see 10 equal parts, and this, let me just highlight it. So this first part, each of them represents 1/10, 1.1. So I'm going to have to take 2 of these because we have 2 in the 10th place. We got 2/10. So that's why I have to take 2 of this. As you can see here, I have from here all the way here, that is my 1. And then another 1/10, another 10th, or you can say 0.1 together, that's 2/10 or 0.2. So this whole paper strip from the left end all the way to the right end, the length, how long this is, represents the number 1.2. So it's not the size, it's the length of the paper strip, not the width. Okay, once we got the first paper strip, make sure when you tape them or when you do the drawing, don't leave any gaps between the first paper strip of the length 1, and the second paper strip of 0.1, and the third paper strip of 0.1. So make sure you don't leave any gaps, because if you leave gaps, it's going to be longer than 1.2. But if we don't leave gaps, we go from here all the way here, that's 1. And then immediately we start 0.1. So that's 1.1. And immediately we start another 0.1, that's together 1.2. Okay, so we got the number, the paper strip for the number 1.2. Now, next we're going to use the paper strip to represent 0.899. So that 8 is 8/10, and 9 is, I'm going to put it up there because I don't have space down here, the hundredths. And then the other 9, the third 9, is the thousandths. And notice that, again, from section 1.2, we learned that the relationship between the place values. So if you want, if you have the ones, I have this paper strip here. This is the 1/10 or 0.1. And how do I need to generate the hundredth. And notice that 1/10, 0.1 divided by 10, it's going to give us hundredths, either 0.01 or 100th. So remember, if you're the place value, when you go from the left to the right, it's always divide by 10, divide by 10, divide by 10. So you can generate the smaller place values. So now we're going to take this paper strip right here, which is 1/10, and divide this into 10 equal parts. So again, I didn't really show that, and so technically you're supposed to use a ruler to help you cut into 10 equal parts. And so this one of them is going to be 0.01 or 100th. Okay, and in order to generate the 1,000ths, we have to take this tiny piece right here and cut it into 10 equal parts, which is almost impossible to do because it's going to be very tiny. So you don't really have to do that, and you can just omit that part and go ahead and just use because we know 0.009, the 9 in the thousandths place, is very close to 100th. So you can just do something a little shorter than this piece here, which represents 0.09. Because again, technically we're supposed to take this and cut into 10 equal parts and take 9 of them. But it's very hard to cut this tiny piece into 10 equal parts. Okay, so now even this one is a little hard to do. But okay, so let's take a look at the paper strip for 0.899. So let's start with the 0.8. So I have 0.1, I have to take 8 of them, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8. Sorry, there's a little bit of gap here. I try my best to put them closer, but it looks like there shouldn't be any gap. There's a tiny gap right here. So that's 0.8. And then now I'm going to do 0.89. So that 0.09 comes from, this is 0.01, so 100th. I'm going to take 9 of these. So I do 1, 2, 3, 4, 5, 6, 7, 8, 9. Again, there shouldn't be any gap. I think I did almost, there's no gap there. And then finally, if there's a tiny bit, I'm going to ignore that. But and then finally, I have to do this last digit. It's 0.009, which is 9,000ths. And again, because it's hard to do, so I'm just going to, I got this tiny piece right here, this little tiny piece to represent 0.009. The 9,000ths. Okay, so as you can see, this whole piece from the left all the way to the end, that is I'm going to label it here. So this whole length of the paper strip represents the number 0.899. But the top one, this whole piece, represents 1.2. Now, when you teach in class, you actually use the real paper strips and you put them, you line up the left end, and you can see the paper strip for 1.2 is this much longer than the paper strip of 0.899, which tells us, okay, 1.2 is bigger. So the students actually can see 1.2 is a longer paper strip than 0.899, which means 1.2 is bigger. Okay, so that's the first method. And next method, the number line method, is easy as long as students understand that. So first of all, we found where 1.2 is, which is right here. And then we found a 0.899, so which is between 0.8 and a 0.9, 0.9. So it's very close to 0.9. So it's going to be somewhere here. So I have 0.899, and this one is 1.2. Now on the number line, the numbers to the right, on the right is always bigger than the numbers on the left. So that's why you can, from the number line, we can see 1.2 is bigger than 0.899. Okay, for part C, we're supposed to use bundled objects. Here to use bundled objects. Okay, so for paper strips, we compare the lengths, see which one is longer. But for bundled objects, we compare how many, so the cardinality, see which one has more, because I couldn't fit them in on this page, so I'm going to have to put them on this next page here. All right, so remember we have these, still have these two numbers, 1.2 and 0.899. So this time when we use bundled objects, remember we cannot cut a paper clip. Like paper strip, I could cut the paper, but if we use toothpick cubes, you cannot really cut it into smaller. So when you do use bundled objects, make sure you start from the smallest place value. So we have, this is the smallest place value, which is the 1,000th. And so we're going to use the 1 toothpick to represent 1,000th, which is 0.001. And this is very important because you don't want to use 1 toothpick to represent 1, because then you have to, if you have 1 here, in order to get the 1/10, you will have to divide by 10, which means you have to cut the paper, cut the toothpick into 10 equal parts, which is very difficult to do. So we don't want to, and then you have to keep cutting another, and keep cutting with paper is already hard enough, and with objects it's impossible. So that's why we don't want to start from the largest place value. We want to start from the smallest place value, which is the thousandths. So 1 toothpick represents the 1,000ths, and then when you want to generate a bigger one, you will have to multiply by 10. When you generate a bigger one, you multiply by 10, bigger place value, larger place value. So we start with that. And so which, if you want to generate 0.01, which is 100th, you will multiply by 10. And if you want to generate 0.1, you will take 10 multiplied by 10, which is 100. If you want to generate a 1, you multiply by 10 again, so you get 1,000 toothpicks. So this tells us you will, in order to do this, if I use 1 toothpick to represent the 1,000th, then I'm going to have 10 toothpicks here, and I have 100 toothpicks here and 1,000 toothpicks here for 1. Okay, so here I have the toothpicks here. So for 1.2, let's start with 1.2. So 1.2, first of all, I need 1,000 toothpicks. So I put it here all bundled together. Each of the bundle, big bundle in here, that's 100, 100, 100. I have 10 of these, so together that gives me 1,000. So this is 1,000 here. And this bundle is 100 here, 100 here together. That's 200 bundles. But by the way, the 200, that's the number of toothpicks. But the value, since the value of 1 toothpick is not 1, it's 1,000th. And if you look at my chart right here, so 1,000 toothpicks actually represents 1. Okay, so it equals 1. And 200 toothpicks actually represents 2/10, which is 0.2. So together, the picture demonstrates 1.2. Okay, so now we have the bundled objects for 1.2. Now let's do the bundled objects for 0.899. So remember 0.88, we need each 1/10, we need 100 toothpicks. So I'm going to take 100, 100. So here we have 8 of them. So that's 800 toothpicks, which represents 8/10, which is 0.8. And for the 100th place, the 900th, we